Hello and Hello and welcome back everyone. I am Neil and today we will be continuing to build our trading bot. This is actually a great video series for me because I'm actually challenging myself to build my daily life and also improve myself and improve my skills. So please don't forget that this is not an actual official tutorial, but it's more of a challenge that I'm testing myself, and also I'm showing you guys how it's going for me. Kind of like a vlog where you guys can also see my progress, learn from me, or comment your ideas and teach me and stuff. So before we do anything else, let's get started. First, we will be starting by reading our CSV file. For this one, we will use pandas read CSV function, and then for the file path, we will give our file path sp500 data.csv, and we will create our date column again, and then we will make sure that it's in the date format. And now that we have our data ready to use, we can start by creating our first and most important features. This will be the features, the prediction of our machine learning model. It will be Y. And for this one, we will use log return, since this is the most important thing we will need to predict the prices, to teach machine learning what to predict and how to predict. And the reason why we will use log will be since it will be better for machine learning models to understand. And here we will get our good close. Actually, let me rename this as gclose so that it will be easier to type in the future. And then here we will get transform, and we will use our transform function. I had to run this again to rename it. And this, of course, and we will use our transform function here, and we will use lambda. And then what we're gonna do here is that instead of defining a function, we will just use this, since it will be much simpler. And here we will say log. We will divide our x by x.shift, so we will shift it by 1 day, and we will get the ratio, and we will get the log of this, and we will save this into our data frame. And this will be our predictions used for the model log return. And we can also get something like actual return, since this will be easier for us to understand and for us to use while predicting, not predicting, but using it to see and plot. So we'll be using this, and here again we will say gclose.transform, and again we will use our lambda function here. And here we will use a function that's already built in, and we will call %change. Yes. And once we run this, we should be able to get these data, and let's check it out by printing the df.head. And as you guys can see, we got our log return and actual return columns here in our data frame. And the first one is none, since we don't have the return here yet. But as you guys can see, this is working perfectly. And this does not exist since we're getting close to close, and since we don't have the close data before the first day, we cannot get this. But yes, so now that we created our prediction values, we can start and continue creating our new features for our model to predict. And the reason for that is because in the basic models that we're going to use, giving the data, the raw data, will cause our models to hallucinate, make prediction errors, and it will not understand how the money works and how the predictions work. So instead we will just be giving ratios, and it will be much simpler for our models to be able to predict without having biases or having other issues with our predictions. So to create our most basic features that we'll be using in our machine learning model will be our SMA, EMA, and similar kinds of features. These features might not be very useful, but they will be helpful for us to learn and to test, and eventually we will improve by adding more features, moving features, and doing more other stuff with our features. So here we will first create our simple moving averages, and for this one we will get our gclose, and we will use our transform function here again. And here we will use our lambda, and we will use a function called rolling. We will be getting the window of 200, so we're gonna get the 200 stocks before the day including, and then we will get the mean of it. And once we run this, we should have our SMA 50 here, and using the same function again, we can just create our SMA 200. We will just need to change our numbers, and this is how we will be creating our SMAs, simple moving averages. And we can also create our EMAs using a function that's built in, which is very useful for us. And here what we're gonna do is we will use gclose, and we will use our transform function. And again, we will be using our lambda x and x dot. For this one, we will be using this function to get the exponentials, and then for span we will enter 20, and we will not be adjusting this since we will be dropping it in the future, so it will not cause any issues. And once we get the mean for this, we should be able to get all of these data we like. And let's see that by this time I will not be printing head, because when we print the head, we will have so non-existent or undefined for our SMAs, because we will not have the data for the first 200 days. So here I will be printing the tail, and don't worry about the empty data, we will be dropping it in the future before we start training our models, so it will not cause any issues with our code. And as you guys can see here, once we print our tail, we can see that we have our log return, actual return, SMA 50, SMA 200, and EMA. And as you guys can see, we can use these in the future. However, before we start using them, we will need to normalize them, and I will show you guys how to normalize them in a little bit. These will be our most basic features we will be using here at first. So here I will be continuing by normalizing our data and also creating a little more useful features for us. And here we will be getting our distance to SMA, let's say 200 here. And the difference between the normal SMA 200 versus distance to SMA 200 is that we will be using, and we can say normalized. The reason we use that is because when we're using this data in our daily lives while looking at a stock, we will be looking at the distance from its normal 200 norm. So what we will need here is that we will need the difference, and we will not be just using the data by itself, but we will be using it relative to the price. So this is what we will be doing here. We will be getting our closed data, and then we will get our distance. And here, as you guys can see, we are deducting the SMA from the close, and after doing this, we will be normalizing it by, oh sorry, I used the wrong name here. Since this is the feature we're creating right now, we're gonna divide it by itself, so that we will have a ratio that will not have the price, the raw price, but it will have the ratios, pure ratios, so that will be much more useful for the machine learning to predict and also not overtrain or memorize the data. This is what we want to do. We don't want our machine learning models to memorize it. We want our machine learning models to be able to see the ratios in the data and work on that. And here I will get the EMA 20 normalized distance from close price again. And here what we're gonna do is the same. We'll just use the same structure, and we will use our EMA 20 here, and then again we will be dividing it by our EMA 20 value. And once we do this, we will get our distance to the closed data, and then the normalized versions of this. Ooh, sorry, as you guys can see, I made a mistake here. Pretty sure some of you guys probably have noticed this. I forgot to use our parentheses here, and this will cause our data to basically become closed, so they're dividing each other by itself, so we're just deducting one. And once we fix this, as you guys can see here, we have negative, so this is showing that we are above the close price, and we are here below the close price. This is useful for machine learning models to be able to understand what is the trend and how it's going, and what's our price data comparing to its past. And this is normalized so that it will not, like I said, have the raw data. And now I will show you guys how to create some more features, and for these features we will be defining functions, and I'll be showing how to use the functions to calculate our new features. Here we will create a function called calculate MACD, and for this one we will have our data series, and we will have fast, and I will give a default value of 12, and I will give the slow a default value of 26. And here what we're going to do is we will have our fast EMA, and for this one we will call it series, the same function we used earlier. And this is important because this is the one we used for calculating our EMA values. And again we will call adjust false, and we will get our mean, and this will be our fast EMA. And by copying this I will just get our slow EMA. It will be the same logic, but for the span we will be just entering slow, and this will be the same function. And what we're going to return here is the series of fast EMA, and we will get deducted from slow EMA. I will show you guys how to use this function in our data frame now. What we're going to do is we will start, and we will use our data frame. We will start and have a new column called MACD. Here what we're going to use is we will use our gclose again, the one we sorted and grouped by, and we will transform it. Now we will use our lambda x, and here what we're going to do is we're going to use our calculate MACD function that we defined earlier. And for the series we will be entering x, since this is our x at the moment, and this should return us, actually sorry, we don't even need to do that. You can just enter the function here, since we don't need to enter any data. We will just say calculate MACD, but if you use it the other way you can also enter the fast and slow data. However, we don't need it right now. And now we can continue by defining our slope function. So I will create a function called calculate slope here, and here we will have our series data again, and then we will have our data of, let's say, 20 as default. What we're gonna do here is that we are gonna get our slope percentage, and the way we're gonna get is that we're gonna get our series, and then we will deduct series.shift. We're gonna shift it by the days of windows we will enter here. This will be the slope we want to give. And then once we enter this data, let me just add one more thing. We can divide it by, again, the same thing. This will help us normalize it. And then once we get our slope, we can normalize the slope by dividing it to the number of days we had here. And here for this we will divide it by window. And once we run this, we should be able to get our slope easily. Yes, and we can again call our function. Not the same way we did, but we can also call it the same way we did. We can choose however we want to call this one. For this one, I will just show you guys how to get slope for the data we gave, or you can use other ways of calculating. Here, transform, and then here we will call our lambda x, and we will use our calculate slope function. And then here we will enter x as our data series, and we will enter 20 here, so I will call this slope 20, and we can just say normalize, since this is normalized. And finally, before we end our video, I would like to show one more thing. We want to normalize our MACD data here, so the way we will use that is we will define one last function called calculate rolling z-score. And this is a function or a method that's used in statistics a lot, and we will have our window of, let's say, 252, and the way we will use is we will get our mean, and we will use our mean, we will get the mean of the data of the last 252 days. And we will use the standard deviation as well. And here what we're gonna do is we will just return an easy function that we'll use here. We will deduct our mean from our series, so we will be deducting the mean, and we will be dividing it by the standard deviation, and this will give us the normalized MACD. So we can just say, let's say MACD normalized, and what we're gonna do is we will just use our transform. But however, to be able to do this, we will need to get the grouped by MACD again, and it's gonna be the same way, group by. This is not an efficient way of doing it, but you guys can do it in a more efficient way than I am doing right now. However, this will be easy to explain right now. So we will use MACD, and then we will transform it as the same way we did earlier, and we will use our lambda function, and we will use calculate rolling z-score function we defined earlier. And for the window, I can give any data, but I will give 252 again. And after we're done with this, we can print our df. We can print our df value, and again I will be printing the tail, let's say 10. And once we print this, we got an error. Let's see what our error is. Stock. I made the same mistake again. I'm just gonna call this ticker. And since we create our MACD value earlier here, it should not cause any other issues. And as you guys can see, we have our normalized MACD. This is a great way of normalizing values that are hard to normalize. We can just deduct the mean out of it and then divide it by the standard deviation, and it will give us a great value. And as you guys can see, we have our distance normalized, EMA normalized, and slope normalized. And thank you guys for watching this video. In the next video, hopefully we will train our first model, and I'm assuming it's not going to perform well, and we will be improving it together slowly in our series. Please don't forget to subscribe to my YouTube channel, and don't forget to like the video. And if you have any improvement ideas, please don't forget to comment those ideas so that we can use these in the future. Thank you guys for watching, and I hope you will have a great day.